Hi and welcome to Axiom Chemistry. In this video we're going to talk about particles in solids, liquids and gases. Now, as we've already seen, some substances around us are solids, like the salt that we used in the last lab. And some are liquids, like the water that we dissolved the salt in. And both the salt and the water are surrounded by air, which is made of a mixture of gases. This photo here shows solids, liquids and gases. The volcano itself is made of solid rock. The water around it is of course liquid, but it won't be a pure liquid. There'll be dissolved solids and gases, as well as various solid particles mixed in. And then pouring out of the top, there's a whole mixture of gases and also lots of small particles like ash. Now, solids, liquids and gases are examples of what we call states, or states of matter. There are actually 4 states of matter which are observable in everyday life. In addition to solids, liquids and gases, there's also plasma. In Axiom Chemistry, we're going to be focusing on the first 3, but you'll learn a little bit more about plasma in the first of the Questions Students Ask videos, which is coming up very soon. Okay, we have already seen that all materials are made of particles. And let's start by thinking about particles in a solid. So, in a solid, particles are packed closely together in fixed positions, something like this. You can see that's a very neat, regular arrangement. Because they're packed closely together in fixed positions, solids have a fixed shape. And because they're all in fixed positions very close together, well, we can't move through them. If you poke a gold bar with your finger, it's not going to give way like water in a glass. However, these particles do move. The particles can vibrate, but they can't move more freely. So they move something like this. Note that they're always vibrating around a fixed central position with no overall movement with respect to other particles. Let me show you that again. You can see that they're just moving around their fixed central positions. So that's how particles are arranged and how they move in a solid. How about in a liquid? Well, like in a solid, the particles in liquids are packed closely together, but this time not with fixed positions. Let me show you what I mean. Here are some particles in a liquid, and you can see that they're very close together, but their positions aren't fixed relative to each other, and you can see they're actually quite randomly arranged. The particles can slide past each other, and so liquids do not have a fixed shape. Let me show you what I mean. Those particles might move something like that. You see, they're moving with respect to each other in a way that they weren't in the solid. That's why if you poke some water in a glass, it will give way. The tiny particles will slide away and let your finger in. Okay, let's now think about a gas. In a gas, particles are spread far apart, something like this. You can see there's a lot more space between them. Now, these particles aren't just vibrating around fixed positions, and they're not just slipping and sliding over each other. No, these particles are moving in all directions and fill the available space. So they're going to move something more like this. Okay, let's go back and think about the volcano. We now understand a bit more about what makes the rock solid, the water liquid, and why many of the particles coming out of the top of the volcano are gases. In the solid rock, the particles are packed closely together in fixed positions, and so it has a fixed shape. In the liquid water, the particles are still packed closely together, but they don't have fixed positions, and they can slip and slide over each other. And finally, the particles in the gases are spread very far apart and can move in all directions, and can eventually fill all the available space. As ever, here is a summary of what we've discussed in this video. We've seen that solids have a fixed shape, that their particles are packed closely together in fixed positions, and those particles can vibrate but not move freely. We've seen that liquids do not have a fixed shape, that their particles are packed closely together, but those particles can slip and slide over each other. And then finally, we've seen that gases fill the space available, their particles are spread widely apart, and those particles move in all directions. As ever, if you haven't written any of this down, I suggest you pause the video and do that now. Well done, and see you in the next video.